Assalamu alaikum warahmatullahi wabarakatuh. Hi everyone, I am Rakan and my colleague Abdulaziz are excited to present an important concept in digital electronics. In this presentation, we will explain convert binary coded decimal numbers into signal for a 7-segment display. This diagram illustrates a logic circuit designed to convert binary coded decimal numbers into signal for a 7-segment display, which is used to visually display digits from 0 to 9. We use inputs S3, S2, S1, S0. This represents the binary coded decimal. The 4-bit input can represent decimal numbers from 0 to 9 in binary format. We use logic gates, NOT, and OR. These gates process the binary input and determine what segment of the segment displayed to activity. The AND gates check specific conditions to light up individual segments. The OR gates combine output from multiple conditions. The NOT gates invert certain signals where needed. The output top left, top right, middle, bottom left, bottom right. This output control of the different segment of the 7-segment display. When a specific value enter an binary coded decimal, the circuit activities in the appropriate logic gates. The output determine which segment of the 7-segment will light up to form the correct number. Example, if value is 3, 1 and is 2 is 1 is 0, 0, the can you show value 8, and is 3, 1 is 2, 1 is 2 is 1, 1 is 0, 1 can show number 9. And if it's 3 0, if it's and it's 2 0, and this 1 0, and it's 0 1 can show number 1. Finally, the circuit converts binary coded decimal numbers into segment signal to drive a 7-segment display, enabling the visual representation of number.
Bismillah ar-Rahman ar-Rahim. So as my colleague Rakan stated that this is a BCD to 7-segment display, what it does is it converts the binary representation of the number into the 7-segment display. Okay, so for example, we can have this 0001, this is 1 in binary. Okay, so it is converted as 1 in decimal. Okay, this is the visual representation of 1. We can have, for example, 2 is going to display 2, 3 it's going to display 3. So we don't want the input to be through the user, as in clicking a button, making this 1, 1, 1. No, we want a counter, we want a clock, we want a button for reset. And this is exactly what we made in this part of the project. Here we have a counter. This counter controls the maximum value that can be presented. For example, it's 9 in this situation, so when it reaches 9 it's going to reset back to 0. And here we have a clock. The clock pulses, and every pulse is converted as an incrementation in the counter. Okay, so every time this clock pulse, the counter increments from 3 to 4, from 4 to 5, and that's it. Okay, so we also have a button for reset. This resets back from to 0. For example, it's going to be 5, we reset it back to 0. 1, 2, 3, back to 0. 1, 2, back to 0. Okay, and also this counter has an input value which has 4 width. Okay, it has 4-bit width, as in this 1001. It has one output. So what we did is we used a splitter to split every bit individually. Okay, so this is what the splitter did. It split every bit individually. Okay, so S0 will take the first bit, S1 will take the second bit, the third bit, and the fourth bit. Okay, this is the BCD to 7 segment decoder which we made in this situation. Okay, so when these inputs go through, they go through the same logic gates, the AND gates and the OR gates, thus representing the decimal representation of the binary form of the number. Thank you for listening. Now, in addition to the project, we have this hardware representation. Okay, in the right we have a battery. This is the positive part of the terminal, and it is connected to the 7-segment display. The negative part is connected through the switch. Let me turn it on. Okay, and all the way to this part. This part is close to the counter, but it has few functionalities. Okay, for example, it has the pulsing, but it does not do the incrementation. Now, if we take out this part, this E part, from the 7-segment display, we can make the representation of 9. If we take out this part, which is F, we can make the representation of 3. And this is what the hardware is about. It helps in visualizing what the project was doing.